So now let's look at simplifying these composite functions with tables. So what we have here is a table where we have this input x, we have these values for f of x, we have these values for g of x. So with that, let's look at our composite functions. So again, we want to work from the inside out. So when I look at this first example, g of f of 2, so that 2 there is my value for x. So what I want to do is simplify. I'm writing the notation for g, but I'm mostly ignoring that function g for now, and I'm just looking at this f of 2. So what this means is when x is equal to 2, what is f of x? So what I'm going to do is go to my table and look at x equals 2, and f of x is that positive 1 right there. So that's where I can replace f of 2 with positive 1. And now I'm going to use my function g of x, where my new value for x is positive 1, and I want to see what the output of g of x is. So what I'm going to do is go to the table and look at x equals positive 1, and look at what is g of x doing, and it's giving me that negative 2. So what ends up happening here is you're kind of moving crisscross across the table. So it's like we started with x equals 2, and then, let me see if I can get this all to work. I'm going to use some pen. So it's like we started with x equals 2, and that led us to f of x. And we got that positive 1. That positive 1 then became the input for our function. So we went to where x was positive 1 and looked at g of x. And that gave us our final answer. So there's this kind of movement of simplifying with f first, and then using the output for f as the input for g to get that output there. Sometimes this visual helps students, sometimes it doesn't work at all. So however that works for you, you can look at it or don't. Either way is fine. All right, let's get all that out of there. So f of g of 2, we're looking at x equals 2, and I want to see what is the output for g of 2. So I'm going to get the outside function structure going with f of, but then g of 2, I'm going to x equals positive 2, and I want the output for g of x, which is that positive 9. So I'm looking at f of 9. So 9 becomes my new value for x. So I want to plug in or look at x equals positive 9 and get the output for f of x. But what we can see from our table is we can't see x equals positive 9. It's not on there. So what we're going to do is answer this with D and E. Just as a reminder, that represents does not exist since it's not defined on the table. All right, our next one, g of negative 1. So we're looking at x equals negative 1 and looking for the output for g. So x equals negative 1, what's the output for g of x? And that's that positive 2 right there. So I'm going to replace the inside function with a positive 2. Then what I'm going to do is look at my new x value of positive 2 and see what the output for g of x is. So at positive 2, the output for g is positive 9. f of positive 1, so x is positive 1, and we want to see what the function output for f is. So I'm going to go to x equals positive 1, look at f of x, which is negative 1. So I'm going to replace that f of 1 with a negative 1. And now I'm looking at x equals negative 1, and what is my output for my function f? So x equals negative 1, f of x is positive 4. So with that, it's all a matter of keeping track of what your x value is, but replacing outputs and inputs and just tracking it along across the table. Let's look at another way to use tables here. We have a table for f of x, we have a table for g of x, and we have a table that we're defining as h of x, which is coming from g of f of x. So what I want in this column for h of x is essentially, I'll write it out in the notation, like this. I want to look at g of f of 0. And here I want to look at g of f of 1, g of f of 2, g of f of 3. So, a few ways we can go about this. I'm going to go the long route first, and then I'll show you the shortcut way. So, the long route here is my next step, and I'll do this in a different color, is I want to simplify the inside of this function. Meaning, I want to grab f of 0, f of 1, f of 2, f of 3. Well, all of those values are listed right here in order. F of 0 is 4, f of 1 is -2, f of 2 is 2, f of 3 is 0. So what I can do is make those replacements. So this is the same thing as g of 4, -2, 2, 0. And then with that, I'm going to get to my last step where I'm actually getting the values for h of x, and that's coming from this next table. It's going to go in a little bit of a different order. So if I want g of 4, I need to look at where x is 4, and we can see that the output for g of x is positive 4. And at x equals -2, the output for g is positive 11. And with g of 2, that's going to be positive 3. And g of 0 is the -8. So that 4, 11, 3, -8, we now have these coordinates for h of x where we have x is 0, y is 4, x is 1, y is 11. It's just we have all this work we need to do before we can find those values. Now the short way, and this is kind of a little visual, but the idea is f of x is the inside function and g is the outside function. So as we did, we started with this first table, moved to the second table, and then that gave us our answers for the third table. So we started at x equals 0. So what you can imagine is we followed this map of, well, x equals 0 went to this output of positive 4. That positive 4 became the 4 as the input for the second table, which gave us that output of 4 there. So what we did is we went input to output, output to input, input to output. Again, the wording in this composition section can be really confusing, but that's basically what we did. And then for our second one where we started with x equals 1, is like we went 1 to -2, found our -2, output of 11 to get there. And with x equals positive 2, 2 to positive 2, found our positive 2, output of 3. And for our input of 3, 3 to 0, found our 0, output -8, and we got our -8 there. So you can simplify it algebraically. Really, you can kind of see it visually moving across the tables as well. Either way works. All right, this last one, we'll have some practice of things we did kind of in that first example, but then we'll put a little twist at the end with some solving. So, finding h of k of 1. So first thing I want to do is simplify this k of 1, where my x is positive 1. So I want to find what is my function output for k when x is positive 1. So x is 1, k is -1. So I'm going to replace that k of 1 with a -1. And then this means now I'm looking at x equals -1, and what is my function h doing? So at -1, h is equal to 0. Oops, 10, 0. All right. H of positive 1, we want to replace that. So we're looking at x equals positive 1. What is h doing? So x is positive 1, h is positive 3. So we're looking at k of positive 3. And with that, we're looking at x equals positive 3. And where is k? And k is at negative 3. For h of negative 2, so we're looking at x equals negative 2. What is h doing there? So at negative 2, h of x is negative 3. It's going to change to h of negative 3. So now we're looking at x equals negative 3, and h of x is at 5. All right, solving. So where we're simplifying, we're working from the inside out. Solving, we're going to work from the outside in. So what I'm going to do is start by focusing on k of what equals 2. So I'm going to ignore that h of x for a second. I just want to fill in the blank of what input do I need for k of x in order to have an output of 2. So I'm going to do is go to my table and I'm focusing on the output values, and I want to see where do I have an output of 2. And that's happening right here. So the input that I would need for my function is 0. So what I just found there is that I know that k of 0 is equal to 2. So what I'm really solving here is now I can look at the inside of the function and know that in order for this to work, I need h of x to be exactly equal to 0. So what I can do is kind of rephrase this now as solving where is h of x equal to 0. It's just I first needed to think of k of x to see that 2 come through. So h of x equaling 0, what I'm going to do is focus on my h of x values and see where do I have an output of 0, and that's happening right here with x equals negative 1. So solving h of x equals 0, the solution would be x equals negative 1, and that would be our final answer to this. So to see how that works is we could check our answer by looking at k of h of negative 1, which would be k of, so h of negative 1 is 0, and k of 0 is positive 2. And that's exactly what we wanted. We wanted to have this solution of 2. We just needed to figure out what would go there for x, and we would need that negative 1. So with that, we work in reverse.